Oxidation number. Let's talk about the rules and practice problems, how we can determine the oxidation number of neutral molecules and ions.
Let's see what are the rules when we are assigning oxidation numbers for polyatomic anions, cations, and molecules. So first rule is oxidation number of any chemical species must sum to the overall charge on the species. If the chemical species you are considering a charge cation or the anion, the overall charge, if you add individual oxidation numbers or individual charges of each element, each atom should be equal to the charge on the ion. That is rule number one. And it must sum to zero for any neutral molecule. If the molecule is neutral, no charge, example H2O, CO2, no charge, neutral molecules, then individual charges, for example, water, hydrogen charge times 2 plus oxygen charge should be equal to 0. And for polyatomic ions, charge the individual charges, individual oxidation numbers equal to the charge on the ion. Next one is the oxidation number of element in elemental form. Elemental form means iron. If you take Fe, this is an element. Aluminum is an element. Those are pure substances, elements, not compounds. Hydrogen, H2, N2, O2, these are elements. P4S8. So you will know what is the difference between element and the compound. Compound means combination, chemically joining of two or more than two different elements together. Two or more than two different elements join to form a compound. For example, H2O, carbon dioxide, NaCl, sodium chloride, and C6H12O6, glucose. They have more than two or at least two different chemical species, chemical atoms, elements. But here P4S8, same kind. P4 means phosphorus, same type of four phosphorus atoms bonded together. Same for S8, there are 8 sulfur atoms, same type. So these are not compounds, they are elements. So all the elemental form, the oxidation number should be 0. Next rule is fluorine has oxidation number -1 when it is in the compound. Fluorine F minus, it is a halogen group 7, so it's form -1 charge. Next one, the metals. Metals are located in group 1, 2, and 3. So metals in group 1 have charge 1. So lithium, sodium, potassium, rubidium, cesium. From top to bottom, they all form +1 charge, +1 oxidation number in the compounds. Group 2 form +2 charge in the compounds. And group 3, like aluminum, they form +3 charge. So in addition to these numbers, zinc and silver, most of the transition metals form variable charges. Variable means more than one charge. But silver and zinc, silver always form +1 charge, only one charge. Zinc and cadmium both always +2, only one charge species. So I hope you can remember when you are naming the ionic compounds for silver, zinc, and cadmium, you do not need to specify the Roman numeral specification because they always form only one charge. If more than one charge, then you need to specify copper 1 oxide, copper 2 oxide, and so on. But silver, zinc, and cadmium, you don't need to specify silver 1 oxide. It's simply silver oxide, zinc oxide, cadmium oxide, because only one charge species. Let's talk about rule number 4. The number of hydrogen, oxidation number on the hydrogen is +1 for the most common oxidation number. However, when they occur in the binary compound means chemical compounds that containing two elements, two different elements. For example, lithium hydride, sodium hydride, calcium hydride. They are binary compounds. So hydrogen is usual oxidation number is +1, but hydrogen is with these binary compounds with metal, then hydrogen oxidation number is -1 because the metals are taking the plus charge, plus character, positive charge, then hydrogen become -1. All the other places, hydrogen +1. Next one about the halogens. So halogen is group 7A. Fluorine, we discussed in previous slides, -1 even in the compounds. Other halogens, chlorine, bromine, iodine, they are -1 charge when they are in binary compounds. For example, HCl, HBr, Hi. Then their charge is oxidation number is -1. But there is halogens, chlorine, bromine, iodine. When they are in compounds with oxygen, then they become positive charge. Oxidation number become positive. For example, chlorate, ClO3 charge is 1 minus. So in this compound, after you calculate, you can see oxygen is -2 times 3, -6. Chlorine charge, if we add both together, is equal the net charge on the ion, -1. So chlorine become +5. So binary compounds charge on these halogens -1, except binary compounds. When chlorine is combined with oxygen, they become plus oxidation numbers, +3, +5, +7, and so on. Next, um, in a neutral molecule, neutral means no charge. Sum of the oxidation numbers of individual atoms should be equal to the zero. When we are writing the equation, we need to add the individual atom oxidation numbers and then equal the zero. However, in a polyatomic ions, cations and anions, sum of the oxidation numbers in individual elements should be equal to the charge on the ion. So example, ammonium ion given here. It is a polyatomic cation. Poly means many, atomic cations, many atoms containing cations. So here overall charge is +1. So how we can figure out nitrogen charge? So hydrogen is +1. So there are 4 hydrogen atoms. So 1 hydrogen 1, 4 hydrogen means 1 times 4 plus the nitrogen charge is equal the overall, the net charge +1. The nitrogen charge become -3. The last rule is oxidation number on the oxygen. So usually oxidation number on the oxygen is -2. However, in peroxides and superoxide, this is different. You can see this hydrogen peroxide or any kind of peroxide, the oxygen charge, if we calculate, it becomes -1. In superoxide, the oxidation number of the oxygen is -half. Because there are 2 oxygen atoms, the overall charge is -1. So -1 divided by 2, it becomes half. Now let's go and find out a few examples based on this set of rules. First one, what is the oxidation number of sulfur in sulfuric acid? Sulfuric acid, H2SO4, is a strong acid. So hydrogen is +1 times there are 2 hydrogen atoms plus sulfur oxidation number as the one we are going to calculate plus 1 oxygen is -2 times there are 4 oxygen atoms should be equal to the charge on the molecule. So this is neutral, then we have to equalize to 0. After you solve that, you can find out the sulfur charge is +6. Next, what is the oxidation number of chromium in dichromate ion? This is dichromate, like potassium dichromate, Cr2/7. Charge is 2 minus. Then the chromium charge multiplied by 2 plus 1 oxygen is -2 times 7 should be equal to the overall charge on the ion is -2. So after you solve, you can see chromium oxidation number is +6 within this dichromate anion. Next, what is the oxidation number of chlorine in Cl2O5? So chlorine charge times 2 plus 1 oxygen is -2 times 5 is equal 0. 0 is the overall charge because this is neutral. So if we calculate, you can solve a chlorine charge become +5. So the oxidation number of chlorine in this compound is +5. Okay, what is the oxidation number of phosphorus on phosphate ion? So you can see 3 minus is the overall charge of this polyatomic cation. Then phosphorus charge plus 1 oxygen is -2 times there are 4 oxygens is equal -3. Then sulfur charge is phosphorus charge is +5. Next, What is the oxidation number of oxygen atom in hydrogen peroxide? So in this hydrogen peroxide and superoxides, you can see oxygen charge is not -2. So let's calculate what is the oxygen charge in any kind of peroxides. So hydrogen is +1 and this molecule is neutral. Then oxygen charge become -1, -1. Next, what is the oxidation number of chlorine in this weak acid H2OCl? So this hypochlorous acid, hydrogen is +1 and oxygen is -2. What is the chlorine charge? So if we add individual charges, hydrogen +1 times 1 hydrogen plus oxygen is -2. There are 1 oxygen atoms. 2 times 1 plus chlorine charge equal 0 is the overall charge of this neutral molecule. So after solve this, chlorine become +1. I hope now you have idea about what are the set of guidelines, rules we need to follow for the oxidation number prediction, and then how we can go step by step for the oxidation number of the any given atom in a neutral molecule or the ion. Thank you all for watching. So if this is helpful, please subscribe the channel and comment any specific area if you need to discuss for future videos.